Cubs, I believe they got a fair shot, huh? Only being back 5 games with like 4 to play. Ready, write this down, ladies and gentlemen. We are talking today about both rounding and estimating. First, we're talking about rounding. And when we talk about rounding, I can't remember, Lace, where was Lacey? Yeah, I think you're right here between Kevin and Ron. That makes good sense. We use rounding when close is enough, when close is good enough. I know I've used this because it's the first thing that comes into my mind. If somebody asks you how much you paid for that, your sneakers, as if you would actually buy anything for yourself, generally speaking, you don't say I paid $36.22 for it. You just say I paid $36 or $40 or whatever, because rounding is good enough. How much is your car worth? You don't go, I paid $75,326.22. You just go, I paid about 75 grand, whatever it is there. Sometimes rounding is close enough. And I'm not going to spend much on time on this part of it because we do this all the time. Let's say you've got the number 5,280. If you are rounding it to the nearest, if you're rounding it to the nearest 10, and I don't like the way any of this came out. Round to the nearest. Now that you're in 7th grade, we don't have to sit there and have to do all this stuff here. If I'm rounding this to the nearest 10, what is my answer? 5,280 rounded to the nearest 10. You're rounding the one in the tens place, which means it's either going to stay an 8 or go up to a 9. It would stay or go up, Kendall. And how do I know? Stay, because the number next to it is a 0. Okay, if this number is 5 or bigger, it rounds up to it. So rounded to the nearest 10, it already is. It's 5,280. Rounded to the nearest 100, that means now I'm looking at the digit in the hundreds place. My choice is either 5,200 or 5,300, in which case Ronnie says my answer is going to be
5,300.
5,300. Again, we don't have to spend a whole lot of time on that. Rounded to the nearest 1,000. My choice is either 5,000 or 6,000. And the answer to that, Aiden, is
5,000.
yes, because the number next to the 5 is a 2. Now, believe it or not, we could actually round this to the nearest 10,000. There's no digit in the 10,000, but you can pretend like there's a 0 there. Rounded to the nearest 10,000, actually, that number is, you wouldn't be very close, but remember, it actually would be 10,000. Right? You could technically do that. You could round it to the nearest 100,000 too, but that's going to give you what? 0. Number, because if I did 100,000, this would be in the 100,000 place, and that's there, and you got enough to that. Now, some special things that I do know that 7th graders do have issues with, and that's when we're rounding to the nearest decimals. Some decimal stuff here. I can't find a good place to do that. Let's do it here. Decimals. Here are the things to remember about decimals, and you will get this wrong, and I'll mark it wrong, and you'll probably poo-poo and cry about it because of blah, 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 blah. Here's the deal. Let's say I've got this number, 75.3684. Okay, if I tell you to round to the nearest 10th, the same rules apply as we do to the whole number stuff there, but rounded to the nearest 10th, what digit's in the 10th place? Roppens? The 3. So again, I look at the number next to it, it's a 6, so the 3 is going to get rounded up to a 4. Now what's different about this, River? 10. Anybody know what I'm going to say here? When you round decimals, notice over here when we rounded things like 5,300, we changed these both to zeros and wrote them down there. When you round decimals, you do not put any digits after the one that you rounded. In other words, round this to the nearest 10th, it is 75.4. We don't make those zeros. For the simple reason is when you say that, this is 75 and 4/10, which is good because I said round to the nearest 10th. If I left all those zeros in there, it is no longer in tenths. Now it is in 75 and 4,000 10,000s, and that's not good. So point number 1 leave off the ending zeros. Leave off the zeros after the one that you rounded. Now, sometimes the one you round ends up being a zero. In that case, you need the zero, but after that, after the rounding. Some of you will forget, you'll get things wrong, but that's just what it is. What about to the nearest thousandth? What is that number rounded to the nearest thousandths, tenths, hundredths, thousandths? That number would be, Charles, what is this rounded to the nearest thousand? 75 point what? Oh, that's nearest tenth. Going to tenths place, hundredths place, thousandths place. That 8 going to become a 9 or stay an 8? What's the number after it, Charles? That mean it goes up or stays the same? Stays the same. It's got to be a 5 or bigger. So my answer is just 75.368. No zeros after that. Don't put them there. If I'm rounding to the thousandths place, so thousandths place is my last digit there. Is that perfectly clear? Yes, sir. Now, the other thing with decimals is this. Not always does the book say round to the nearest tenth or the nearest thousandth. They will say round to the second decimal place. Whoa, whoa, whoa. Round to second decimal place. And you just have to get used to the jargon. Second decimal place just means 2 places after the decimal, believe it or not. So second decimal place is the same exact thing as rounding to the nearest hundredth. This is the first decimal place. This is the second decimal place, third decimal place, and so on and so on. Fourth decimal place. It's pretty logical, but people have a hard time with that. Are you with me on that? So here, let me give you one. 200.4869. That number rounded to the second decimal place would be, Brendan Massey, what is this rounded to the second decimal place?
200.4
9. And again, you don't put any zeros after that. 2 places after the decimal right here, second decimal place. If you're happy and you know it, shout hooray. And then last thing we have to talk about, which again will be very short, we got a blank piece of paper. And it is called estimating. Estimating is basically, as the book says, approximate value. Now, sometimes people get estimating and rounding confused. Sometimes you do rounding to get estimating, but you have to be careful with this. Let us say that, oh, I don't know, Chloe went to the store. Chloe, what did you need at the store? Okay, specifically? Okay, let's say Chloe bought a shirt. What was the exact price of this shirt, Chloe?
$26.95.
Alright, she bought a shirt for $26.95. Chloe also bought something else. What else, Chloe?
Shoes.
Shoes. How much were these shoes? Exactly. $59.49. And then, Chloe, one last thing you bought was?
Ice cream.
Ice cream was apparently what store this was, I don't know. And how much was this ice cream?
$5.95.
Yeah, you must have been to Dunkin' Donuts or whatever, the ice cream place downtown or whatever it was. Okay. And the directions, if the directions tell you estimate how much Chloe spent. How much did Chloe spend? Here is what this is not. This is what I see people doing. You have to see this. This is not, you take what she spent, $26.95, $59.49, and $5.95. I've seen people do this. They add all this up. What is this? 9, oh, look at all the 9s. 18, 19, 23, 2, 8, 17, 22, to $92.39, and then they take that number and they round their answer to, let's say, they say, well, she spent $90. Okay, that's a hard and a big no. When you're doing estimating, you round the initial numbers to make the math easy to do so you can get a quick answer. This was just goofy because it spent me forever I already know the exact amount. I'm not going to estimate my exact amount. I'm going to say, okay, Chloe spent about, $25 there, she spent about $60 there, she spent about $6 there, and I end up with $91. That, ladies and gentlemen, is estimating. You know, you're getting close enough so the math you can do quickly to see to see kind of a roundabout what it is. You don't do all the work and then round your answer. You round to find your answer. You get the gist of that. And I've seen too many people go through this whole thing and they do all that work when really it's just a simple little thing. Let me see if there's an example of what we can do for that. Yeah, look at page 111 for me, will you, youngsters? Look at example letter G on page 111. It says Gus works 39 hours for $9.85 an hour. He calculates that his weekly paycheck should be $38,415. That's a pretty hefty weekly paycheck. If you were estimating how much he should make, what would be the quick calculation on that? You would make 39 hours probably 40 hours and $9.85 to $10, and then you're just saying, okay, 40 hours, $10, yeah, $10 at 40 hours is estimated he should get how much? $400. That's what his weekly paycheck should be. Now, where did this guy go wrong? I don't know. He must have got his decimals all mixed up or whatever, but that's, you know, how do you suppose he arrived at his calculations? He forgot to move the decimals over or did something, I don't know. But this would be the estimation of that. Make the numbers easy to work with, give an approximate value. Don't do all the hard math and then round your answer, round to get your answer. We call that compatible numbers. Make some nice, compatible, easy to use numbers. This, ladies and gentlemen, concludes today's exciting mathematical lesson.